Hello, everybody, and welcome to today's presentation, Why You Should Not Use an RDBS for Time Series Data, brought to you by InfluxData. I would like to introduce you to our presenter, Sonia Gupta. Sonia is currently a software developer in Denver, Colorado. Prior to becoming a developer, Sonia was a lawyer in Louisiana. She served as a public defender in New Orleans after Hurricane Katrina, then as a prosecutor, and finally as an assistant attorney general doing civil rights litigation. Sonia is an outspoken advocate of diversity and inclusion in tech and in life. She is passionate about fostering empathetic and effective communication on engineering teams and believes that even if tech can't always change the world, technologists absolutely can.
Hi, everybody. It's really a pleasure to be here. Like Billy said, my name is Sonia Gupta, and I'm a developer advocate with InfluxData. And today we are going to talk about why you should not use a relational database system for time series data. So let's jump right in. All right, so let's go over the agenda for today. Why are we collecting timestamp data? What is time series data? The differences between time series databases and the Influx data model. Why collect time series timestamp data? The general answer to that is that you want to measure the performance of things. You want to track change over time. So that's why you're collecting timestamp data in the first place. So let's talk a little bit more about that. So when you are collecting timestamp data, there might be a number of different applications that you would be collecting it for. The first would be IoT devices. You would have industrial settings like factories, the oil and gas industry, and then you also have consumer wearables, for example, like your Fitbit or your Apple Watch. You will have sensors on those devices that transmit timestamped readings, measurement statuses, or other metrics back to a centralized repository. So generally in those kinds of situations, in the industrial setting, for example, you want to make your processes stronger, and you want to be able to look at as much data as you can to make those processes stronger. You need really precise, real-time data. And in the consumer arena, you have probably millions of users, so you may not be collecting a number of different metrics on a single user, but you have millions of users, which means you have a lot of timestamp data that's being collected from wearables and things like your Nest thermostat. So you have a volume issue there when you're collecting that kind of timestamped data. Another area in which you might be collecting timestamped data is infrastructure, IT infrastructure and DevOps. So as infrastructure stacks become more complex and more distributed, timestamp data helps you to manage the health of the various hardware, software, and networking components of the system. So we have more and more tools. If anybody here is involved with DevOps, I've dabbled a little bit here and there, and I know that the ecosystem is really hard to keep up with. We have more and more tools. We have Docker, Kubernetes, we have Istio, we have Helm, we have things that are related to Kubernetes, we have continuous integration, continuous delivery tools. So there are always more tools being added to the ecosystem, and those tools need to be monitored. They're constantly evolving, and so you need time series data that can pull in all of those metrics, timestamped data that can pull in all of those metrics from those various tools. Finally, another use of collecting timestamped data might be real-time analytics. So as data-driven cultures expand throughout an organization, many teams rely on timestamped operational or financial data to help inform decisions. So think about things like stock data, high-frequency trading. You need real-time analytics to most efficiently process that data. So you want to know how well, for example, a commodity is being traded over time. Again, there's that change over time component. So IoT, DevOps, and real-time analytics are three of the areas that you might collect timestamp data in the course of your work. So DZone did a database technology survey last year asking, are you currently collecting data with timestamps associated with it, e.g. when an event happened or when data was collected? And the overwhelming majority of people said yes. So time series data, timestamp data is is something that's really widespread. It might not even be something you think about as timestamp data, but really all data is timestamped, right? But we're talking about data where time is a first-class citizen. So people are collecting this kind of data in overwhelming amounts. So let's talk a little bit about what time series data is and what the differences between two types of time series. So you have regular versus irregular time series data. Timestamp data can include data that is generated at regular intervals, which we're referring to as metrics. That meaning the data is routinely collected as a sample or a snapshot at a given time interval. You also have irregular time series data, and we're referring to those as events. And those are measurements that are gathered at irregular time intervals. So some examples of regular and what we're calling metrics time series would be a temperature sensor that maybe is collecting temperature reading every minute and returning that information to you. So that's coming in with regularity, it's predictable, you know what you're getting. An example of irregular time series data might be something like ATM deposits and withdrawals. That's data that's timestamped that isn't happening with any kind of regular cadence. It's unpredictable. You're not sure when that data is coming in, but you need to collect it nonetheless. And as an aside, InfluxDB and Influx, the tick stack is able to process and capture both metrics and events. Prometheus at this point only captures metrics. So just to recap, what we're talking about here are metrics and events. And this is what time series data will fall into one of these two categories. Regular time series being measurements gathered at regular time intervals, and an irregular time series being measurements gathered at irregular time intervals. So something interesting happens when we're talking about events, and remember those are irregular time series data. Let's suppose you're summarizing the average number of deposits that a person makes using an ATM per day over a 10-day period. That's a summarization of events of an irregular time series data, and what you end up producing is something that becomes a regular time interval because you decided to summarize irregular time series data. So that becomes metrics. Now, sometimes your raw time series data isn't going to tell you anything useful, right? An individual data point or even a series of individual data points aren't alone going to necessarily give you any kind of meaningful information, but summarizing and averaging that information might show you trends. It might even show you anomalies that are happening in your system. So that's a really important use of time series data, the ability to summarize and average those events and use other summarization techniques as well. So let's talk about the characteristics of time series data. It is always timestamped, right? Time is a first-class citizen in time series data. It's generated in regular metric and irregular event time periods. You're dealing with huge volumes of data, and you're dealing with data that's real-time and time-sensitive. Let's talk a little bit about each of these different attributes of time series data. So once created, time series data tends to be immutable. Those point-in-time measurements aren't changed, and new data is generally appended to the data set rather than revising previous data. So you want to have a database that's able to very quickly append rather than update data. You're not talking about changing old data, you're talking about adding new data, appending it to a series of other data points. Another thing is that time series data sets are designed to track changes over time, but not all time periods are of equal importance. More recent data is probably the most useful and actionable, whereas the granular details of older data may be less relevant. So you want something that can prioritize more recent data and can help you storage-wise. For example, you don't want to necessarily be storing a whole lot of old data, so you want something that can help you to either downsample that old data or evict it. And you also are dealing with huge volumes of data. So this is not just your regular CRUD application, right? You're dealing with data that's coming in at a high volume at a high rate. So this data is also time sensitive. You need to know when there's a problem, what is happening. For example, if you're monitoring a system, And you need to be able to transform that data quickly to see useful patterns. For example, using machine learning to find any anomalies. You also need to be able, like I mentioned, to be able to read and write quickly rather than update. Updating is not a priority when you're dealing with time series data, but reading and writing quickly are priorities. So let's talk a little bit about what is a time series database in the first place. Obviously, Influx TV makes a time series database, and we're going to talk towards the end of this presentation. We'll do a little demo to give you an idea of how InfluxDB in particular works, but let's do an overview of time series databases in general. So time series databases are optimized to treat timestamp data as a first-class citizen, as we mentioned. Some of the commonalities include the database scale that is often a primary concern with many databases supporting clustering for high availability. Time series databases optimize for large scans over many records. Many of these time series databases facilitate better query performance through column orientation. You have high incoming data volumes requiring high performance writes. So those seeking real-time analytics also need high performance reads in addition to those high performance writes. Time series databases also have a data lifecycle management process to handle data as it ages. This can include aggregating older data to a higher level of detail in addition to creating data retention policies. So what I was talking about downsampling or evicting old data because that data becomes less useful over time. Many time series databases also attempt to simplify the challenges specific to time-based queries, such as handling time zones or providing filters for things like days of the week. So compare what you're doing with a time series database to what you would be doing with a document database, a search database, or traditional relational databases. Now, we're not saying that you can't store time series data in alternative databases like a traditional relational database. You absolutely can, but what I would posit for you and what I want you to think about and what I think you'll understand hopefully by the end of this presentation is that other databases aren't going to be optimized for time series data. So you want to pick the tool that is best for what you're doing. If you're dealing with high volumes of time series data, you're definitely going to want a database that is optimized for time series data. So if you were to be using a traditional relational database or columnar database or search databases, you can use them for time series. And let's talk a little bit about each of those. Columnar databases. Column-oriented databases like Cassandra are a common substitute for a time series database. They are designed to scale. And in fact, some time series databases are written as layers on top of columnar databases, notably Cassandra or HBase. Then you have search databases like Elasticsearch. They can be really good choices for housing time series data because of their ability to rapidly query metrics at a high volume. And then you have a traditional relational database. Relational databases can be optimized for time series data, but scale often becomes a challenge after some time. It depends on, remember, we're dealing with high volumes of data. So scale becomes a challenge, but there are plenty of instances of people using relational databases like Postgres for time series data. So just keep in mind, remember that high volume read and write is a focus of a time series database, and it may not be the focus of any other kind of database. You could build tools on top of another type of database, a relational database, for example, to optimize for high volumes reads and writes, but you're going to have to maintain those tools, and over time that can become very onerous. So you want to use the tool that's right for the job, one that's optimized for high reads and high writes. And that's where you find a time series database will come in handy. So let's look at some time series databases and some other database types. So you've got, for example, other database types that a lot of people are familiar with: Cassandra, MongoDB, Elastic, and Redis. And then there are some time series databases that have very specialized functions. For example, KX is used for high frequency trading. OpenTSDB and Graphite are both used in finance. So you can think about those kinds of applications where timestamp data is really high volume, so you need a specialized time series database, particularly in the finance industry. So DZone did another survey in 2018 asking people, how do you persist time series data? There are a lot of people using relational databases, so you're not alone if that's what you're doing. It is obviously, as we mentioned before, something that works. You can do it, but it's probably not optimal when you're dealing with large volumes of timestamp data. So let's see, 18% of people mentioned that they were using a non-time series specific NoSQL database. I thought that was kind of interesting. And 12% of people are using a specialized time series database like InfluxDB, Druid, or Prometheus. So those numbers are telling in terms of what people are comfortable with and what people have had exposure to. And hopefully by the end of this presentation, you will have had more exposure to a time series database and understand some of its utility, where a relational database might let you down. So in that 2018 survey, DZone asked, what database management systems are you considering? And InfluxDB is pretty high up on the list. There were Druid and KDB were some other options that people were considering. So we're glad to see that Influx is being considered by so many people as an option for you for storing and querying time series data. And let's look at how time series data is growing as a category of the kind of data that people are storing. It's growing. It's the fastest growing category among types of data being stored, as well as InfluxData being the leading time series database. So we're really happy to be leading the pack on this. Influx database is kind of has optimized and has kind of gained the market share in this. We also have a vast open source community, and I think that's probably one of the drivers of why InfluxDB has been so successful, is because the OSS product is so easy to use and so useful even for large corporations. So among all of those time series databases that we've listed, why would one choose InfluxData in particular? Let's talk a little bit about what InfluxData does, what InfluxDB is all about, and some of the ways. We can even get started talking a little bit about how one might populate an InfluxDB instance, understand a little bit about something we call line protocol, and we'll finish out with a demo. So first, let's talk a little bit about why you're using InfluxData in conjunction with your time series data. So our platform strategy is to be the platform of choice for all metrics and event workloads. There is a workflow here that you see that is what we're kind of keyed in on. This is the workflow that we want you to be able to adopt ideally when you use InfluxDB. So you would start with instrumenting, then observing, and then learning, and then acting. That automation there, we'll talk a little bit more about each of these four components. So Influx can be used for IoT sensor events, can be used for business metrics, can be used for application, custom logs and traces, and infrastructure and application metrics. These are all the different kinds of metrics that you can use to store in InfluxDB. And let's talk a little bit more about each of those components and about instrumenting, observing, learning, and automating. So when you're instrumenting, let's suppose you have a drone that is sending you data on a periodic basis. Let me close this calendar. I'm going to miss stand-up for y'all. So let's suppose we have a drone that's sending us data periodically. We want to be able to quickly ingest that data. We want to be able to efficiently store, compress that data at scale. So something like a drone or any other IoT device is going to be sending you large volumes of data very quickly. And so that compression, the ability to compress that data at scale is really important, especially if you're dealing with something like what we were talking about earlier, like the oil and gas industry, for example, monitoring parts of their infrastructure, right? You want to be able to keep that data and compress it because you're going to have a lot of it, and storage becomes a concern. So you want to be able to optimize your storage as well without overloading with too much old data. We also want you to be able to observe your data. So InfluxDB supports real-time querying, analysis, and visualization of large data sets. And we provide time-based functions for change over time analysis and control. So there are 4 components of the TIC stack. Telegraph, TIC being T-I-C-K, in case you're unfamiliar with it. The T stands for Telegraph. The I stands for InfluxDB, which is the database. C stands for Chronograph, and K stands for capacitor. And some of this querying, analysis, and visualization of large data sets is something that would be handled by capacitor. And we're going to talk a little bit more about those 4 components later on, but I kind of wanted to bring your attention to what parts of the stack are actually doing what parts of the stack are actually performing these platform features. So in this observation, we want you to be able to watch what's happening to your data in real time if necessary, and also perform any kind of advanced calculations or processing of that data. And what's the point of instrumenting, of receiving data and observing it? Obviously, it's to learn, right? We want you to be able to learn what is happening with that data, pick up on any trends. For example, machine learning and anomaly detection algorithms. You want to be able to use that time series data to decipher trends in your data, to decipher what exactly is happening overall. If you're looking at averages and summations of your data, we want you to be able to learn from that data what exactly is happening with your systems. So you also need to be able to receive streaming analytics for data in motion. This is your ability to really have a window into what is going on with your data and what kind of trends are occurring in your system. And then finally, what do you do with all of that learning? You don't want to have to monitor everything and do everything manually, right? That's kind of defeats the purpose of having time series data to monitor all of these events. You want to be able to automate. So we want you to be able to have automation and control functions and to evict and downsample data. So this automation and control is something that you would see, for example, in DevOps monitoring, where we want you to be able to kind of fully move into the realm of automation and less sort of manual interference. And then evicting and downsampling data, again, that will optimize your storage. You don't want to keep old data that doesn't have a lot of value. You want to be able to set the duration that you want to keep that data and then evict data that you no longer need. And that is something that you can do with InfluxDB. It's built into InfluxDB. It's not something that you have to tool separately on your own. So you want to be able to look at your data overall very quickly. You want to be able to build analysis and change over time and predict what's going to happen with that learning and automation cycle. And with time series data, the precision of that data is not as important as time passes. So again, that's another reason that you want to be able to evict and downsample data. So let's talk a little bit about the InfluxData's products and offerings. There is the platform as a whole, as I mentioned, consists of 4 components. Telegraph, which is our agent for collecting and reporting metrics and events. InfluxDB, which is the time series database that has been purpose-built for time series data. We have Chronograph, which is our complete interface for the InfluxData platform. It's a visualization and querying tool, and we're actually going to take a look at that towards the end of this presentation. You also have Capacitor, which is our real-time streaming data processing engine, which is going to handle a lot of the information that you glean from that observation process. We also have, and so those 4 components are part of the open source. Anybody can use them. You can get up and running in about 5 minutes, and I'm going to show you how. So those are parts of our open source core. We really encourage you to jump in, download the 4 components, or you can start with the Sandbox, which we'll talk about towards the end of this presentation. But we also have commercial offerings, and those differ from the open source core in that they offer clustering manageability and security. So you have Influx Cloud, which is what, we'll host it for you. We'll handle everything for you. It's pretty much turnkey. You are taken care of fully. We monitor your systems and make sure that everything's good. Influx Enterprise is self-hosted, so that's where you'll be hosting on your own servers. So those are our commercial offerings, but you really get a lot of usability with the open source core. So these are the 4 components of the TIC stack and how they interact with each other. So let's start with Telegraph. Telegraph has input and output plugins that you can receive inputs from various sources like system stats, networking, logs, and traces, and then you can output using output plugins. You can output to various sources, one of which is InfluxDB, and a number of other databases as well. I think we have something like over 200 plugins, and I will show you a little bit about those plugins later. And so that you can kind of get an idea of the functionality that you can get with Telegraph for collecting and reporting your metrics and events. So then we have InfluxDB itself, which is the TimeSeries database. Then we have Chronograph, which is the visualization layer. That's kind of my go-to when I'm playing around with the TIC stack, which I've been doing a lot since I started here about 3 months ago. My best learning in dealing with the TIC stack has been through Chronograph, because I'm able to visualize what I'm doing. I'm able to make queries through that interface rather than having to jump into the CLI. But I'm going to show you both ways in any case, so that you'll have some familiarity with how to get around and how to navigate the system. And then finally we have Capacitor, which is used for anomaly detection, machine learning. You can have user-defined functions. So that's our real-time streaming data processing engine. We really want you to use the open source. We have 188,000 instances of InfluxDB out there. Huge companies are using the open source offering, like CERN, for example, not a company, but an institution. The Large Hadron Collider, that's pretty cool. So it's pretty awesome that CERN is using us. And also Target is using us, using the open source. It's really a great tool. It's often sufficient for people's needs to just use the open source. So it's really a great way to get familiar with the product and at no cost to you. So we really encourage you to download and try that. And I'm going to show you how you can download it, both individual components of the stack and also using the Sandbox, which is the way that I got started, and I found the Sandbox to be really useful. So let's talk a little bit why, of all of the TimeSeries databases, you would want to pick InfluxDB. It's easy to get started with. It has a familiar query syntax, and that query syntax, there's actually 2 query syntaxes now. We just came out with a language called Flux, which is in technical preview. So I will show you actually a Flux query and give you some exposure to Flux if you want to start playing around with that query language. But the language that we've had before that is still supported, is probably always going to be supported, is InfluxQL. And that is really similar to SQL. So if you're familiar with SQL, you will have no problem diving in. Even Flux, so for me, I came from a background where I was more familiar with SQL. And when I looked at Flux, it is really intuitive. It uses a pipe, so you're actually filtering down your data at each level. We'll look at what a Flux query looks like, and you'll kind of see what I mean about the intuitiveness of it. Another aspect of InfluxDB that makes it really powerful, and that makes it something that kind of is standalone, right? It doesn't have external dependencies. So that's what we mean when it was purpose-built, right? It was built for TimeSeries data. It was built to be standalone, and it was built to withstand any kind of adaptations that external dependencies might require. InfluxDB also allows for regular and irregular time series data, which we mentioned before. Remember, metrics are regular events, regular time series data, sorry, and events are irregular time series data. So you can capture both with InfluxDB, which is not the case with every time series database. It's also horizontally scalable. And then finally, it's a member of a cohesive time series platform. So that's the TIC stack. So you will have everything that you need at your fingertips, all in one kind of family working together, built to work together if you are using the TIC stack. So that will reduce overhead costs. It will reduce the amount of education that you need to bring to other developers on your team if you decided to use the OSS version. It's really nice to have everything all in one place instead of having to search and dig around for tools to manipulate and actually interact with your database. So you have everything in one place when you use the tick stack. So let's go a little bit now into some of the nuts and bolts of the InfluxDB data model. I wanted to kind of give you an overview of how data gets ingested, what the protocol is for ingesting that data, so that you have an understanding of how to get started right away. So hopefully by the end of this presentation, after you've seen a short demo, you will be able to dive right in and start populating your database with data. So InfluxDB data points look like this. We have here a stock market graph showing a stock price with the ticker type, the market, the price, and a timestamp. So what you're seeing here, this first thing, the stock price, is your measurement. So you can think of that as sort of the title of a table. If you're kind of in SQL land and you're thinking about what an SQL table might look like, an SQL database table might look like, you can think of your stock price as the title of that table. A ticker is a tag, market is a tag, and price is a field. And then finally you have your timestamp. We'll talk a little bit about each of those components and what they do and why you would choose to name something a tag as opposed to a field. So this is line protocol. You start with your measurement, that's stock price. Your tag set is your ticker and your market, and then your field set is your price. The stock price and the measurement and the tag set are separated by a comma, and then you know that you've entered the arena of your field set when you have a space, no comma. Everything after that is your field set until you get to a timestamp. Now the timestamp is optional. If you don't put a timestamp in, InfluxDB will calculate that timestamp, I believe, according to UTC. So this is an example of line protocol. This is how InfluxDB ingests data using this particular protocol. Let's look a little bit deeper into this data ingestion format. So points are written to InfluxDB using this line protocol. And this is a little bit better of an illustration, I think, that shows you really exactly where your measurement, tag key, and tag value go, as well as your field key, field value, and then your, I guess it's a Unix nano timestamp. So this is how, when you're inputting data, and I'm going to show you an example. I know this seems probably a little bit abstract right now. I'll show you an example of how exactly you might populate your InfluxDB instance with test data, for example, if you're just interested in jumping in and playing around. So what is a series? This is some lingo that you need to know. When you go through the docs, which are really, really quite good. As someone who was completely unfamiliar with InfluxData before I started here, I didn't know much about the tick stack. The documentation was really helpful, but you'll see some terminology in there. One of the words that you'll see often is a series. So what is a series in InfluxDB? It's the measurement plus the tag set. That's the series as a whole. And then the measurement plus the tag set plus the timestamp is a single data point. So you can think of your points as rows in an SQL table, if that helps you to sort of visualize what we're talking about here. So let's look at some examples of points in line protocol. And the first one is one that you will see if you get the Sandbox up and running, because Telegraph will automatically start pulling metrics from your machine, and you'll be able to see great graphs of like system usage, CPU, various other metrics right off the bat. So that first one is a good example of something that you'll see, and you can see it in Chronograph right off the bat when you start the Sandbox. Another one would be this temperature and zip code. With temperature as your measurement, and then zip code, your country, are both tags. And then value and humidity are fields. And again, the same kind of thing is happening with response time being your measurement, method, precision being tags, and then value being your field. And that one has a timestamp, which again is optional. So let's look a little bit into how this actually works. Hopefully this live demo will go well and everything will go as expected. So let me switch over to my screen. All right. So let me show you the Sandbox. First of all, let me show you where you can get that from. Here we go. I'll post this in the chat channel if I can get down here. So this is where you can get the Sandbox. It's really easy. All you have to do is have Docker installed on your machine. Then you just clone down the repo here and run a series of commands to get it up and running. So I'll show you what exactly we do to get it up and running. Oops, no thanks. I'll remind me later. We're not going to do an install in the middle of this demo. So this is actually what the files look like when you clone down that repo. You'll see there's a Docker Compose file, and then there are configuration files for each of the components of the stack. I want to take some time and look at this Telegraph configuration. You can see I was talking earlier about inputs and outputs. So automatically out of the box, this is configured to send inputs like your CPU here, your system information to InfluxDB as an output. We also, since this is running in a Docker container, or a series of Docker containers rather, we have an input for Docker, which will actually be able to monitor that too. This week I was playing around with running Elasticsearch locally on my machine, and there's an input for Elasticsearch, which I got up and running just by doing this. I will give you this one little caveat. Since you are dealing with Docker containers, if you want to be able to communicate with a service running locally on your machine, you'll have to configure it this way rather than just using localhost. So if you run into that snag, which I ran into, now you have the solution for that. But this is me taking inputs from Elasticsearch when I run it locally on my machine and outputting them, and they will appear in Chronograph. So let's, Sandbox, I already have it up and running, but to get it up and running, you just type Sandbox up. Let's look at some of the commands that we have available to us. I'll make this a little bit bigger and big in this. So you have a Sandbox up command, and you can also get the nightlies, which is what I've been playing with because there's always something really fun and interesting going on with the nightlies. And then you can go ahead and enter each one of those containers. Well, I'm sorry, this one is to attach to the Influx CLI. But you can actually enter any one of these containers and see what's going on. You can also stream logs from those containers. So let's go ahead and enter the InfluxDB container right now. All right, so what I want to do is show you how you can run a Flux query from this Influx CLI. We'll also show you how you can do it using Chronograph. So this is how you establish that you want to use Flux instead of InfluxQL, which is our older querying language. So here you go, you've entered this. Oops, didn't mean to paste that, sorry about that. I have a query written out because I didn't want to take too much time writing a query. Let's look at it. It's here. And I'm going to walk you through this when we look at Chronograph. It's a little bit easier to visualize, but I just wanted to show you here that you can run queries. So I've already populated my Influx database instance with trained data. I'll show you how I did that. I used Postman. You can actually, you can populate your Influx database instance either using the CLI, or you can write to the right endpoint once you've got it up and running. This is the name of my bucket is trains, and so I have these measurements here. The measurement is train speed, then I have train, driver, location as my tags, and then I have speed, track temp, and outdoor temp as my fields. So I actually just made a post request to this endpoint to populate my database with all of these different data points. And again, the timestamps are optional. I just kind of put in a bunch of random timestamps because I wanted to have data that looked old while I was playing around. So this is exactly what we just got back from that Flux query, is that data that I populated. And this is giving you a raw view, so you kind of get an idea of what you're getting back, whether you're getting back exactly what you need. And to exit out of this, do a Control-D, not Control-C, as I learned. So that's one way for you to query and populate your database, is using the CLI. Now I really want to show you my favorite part is using Chronograph. So this is Chronograph. Again, when I told you when you get started, you're going to have Telegraph is already pulling information from various parts of your system. So you can see CPU usage. I'm not quite sure why these are not populated right now. You can see what's going on with your Docker containers, how much memory they're using. You can also look at the InfluxDB instance itself. This one's really useful. Breakpoints is how many points are being written over the course of time. So on the Explore tab, you have the option of writing InfluxQL. So this is what an InfluxQL query would look like. This is something that you can do through the CLI, which I just showed you a Flux query there. You can also do an InfluxQL query. Just make sure you don't set the type to equal Flux. And this is basically just a select all from that same trains measurement that I set up. Sorry, train speed measurement. So this is my measurement here. This is just giving you all of my data points. So the other option is if you'd like to dive into Flux, this is how you would make a query using Flux. So you always have to specify which bucket. A bucket is your database. So my database is named trains. You always have to specify a range. And then you can start filtering by various functions. So I've filtered here. I only want train speed. I have another measurement actually in this database. You can have any number of measurements in a database. I have another measurement called passengers in car. So I only want to see what's happening with my train speed measurement. So I can group those by driver, which you can see here. Those have been grouped. And then I've done this really fun, function, this pivot function, which allows me to see all of my individual fields fleshed out into separate columns. So there are so many. This is just like the tip of the iceberg when it comes to Flux. But this is kind of a fun query to get you started. I can post this in the channel as well. The Flux docs are forever growing, and they are changing things on it. It's still in technical preview, so things are still changing and evolving. But it's really kind of fun to start diving in and playing around with it. Let's see, is there anything else I wanted to show you about? Oh yeah, Chronograph is really cool for visualizations. I picked a table visualization here, which you can see, but you also have options for line graphs, stacked graphs, step plots, bar charts. It's really powerful for that. So not only can you use Chronograph to run your queries, but you can actually use it to visualize your data as well. So that's really powerful. And here you have this kind of like helpful list of all of the Flux functions available to you, along with documentation on how to use them. So that's all I have for everybody today. I hope that this was helpful, and I hope that you'll be able to dive in and get started using InfluxDB. If you have any questions, please go ahead and ask them. We also have a community site, which is really, really awesome. I'll post the link for that in the channel as well. It's a great place to get questions answered by me and by other DevRels, but also by the community at large. You'll see it's really active. People are always kind of interacting with each other. There's me, I just answered a question. I feel proud of myself for that. But you'll see other members of our DevRel team here, as well as some super users who really contribute a lot to the community. So we really highly encourage you to jump in here and start reading about the product using the community site. It's a really great resource to learn and ask questions if you get stuck. That's all I have. And so if you're ready with questions, we can dive right into those. And I appreciate you taking the time to be here with me today and listen and learn with me. So looking forward to your questions and looking forward to hearing what you think about InfluxDB after you've been using it for a little while. Thanks.
Thank you so much. We do have a few questions that have come in. The first question is, how does InfluxData compare to TimeSeries features provided by analytics databases such as Teradata and Vertica?
I don't know the answer to that question because I'm not familiar with those particular databases. So it might be something that I can find out from my team. Chris, do you know anything about that?
Not specifically, but we can post that to the community.
Yeah, we'll do that.
Awesome. The next question that we have is, what language is InfluxDB written in?
It's written in Go. Go is pretty cool, and there are some really awesome functionalities that Go allows us to build InfluxDB with. So yeah, it's pretty cool.
Next question that we have is, how is InfluxDB different from Elasticsearch?
Okay. InfluxDB is optimized for time series data. Elasticsearch is optimized for search, right? So Elasticsearch isn't necessarily, in my estimation, I'm sure maybe there are people who have other opinions about this, isn't really optimized for high write capacity the way that InfluxDB is. So it's meant to be a document store, right? It's meant to store things that will come back to you in JSON format. It's not meant to store time series data. It wasn't optimized for that. So that's kind of my view of it. You obviously can use Elasticsearch for time series data, but it probably won't scale as well as a time series database would.
Great. The next question that we have is, are there connectors from InfluxDB to visualization tools such as Power BI or Tableau?
I don't know about Power BI or Tableau. I know that a lot of people use Grafana with InfluxDB, so you're not forced to use Chronograph. I'm not sure about those other two products, but there are other alternatives. You don't have to use Chronograph as a visualization tool.
Great. The next question that we have is, what are some of the ways I can write data into Influx?
I'm sorry, can you repeat that?
Yes. What are some of the ways I can write data into Influx?
Okay, sure. So I just showed you a couple of ways that you can do that using the CLI or using a curl request or using something like Postman to write your data to InfluxDB. But you also, obviously, in a real-world application kind of situation, you have various Telegraph plugins probably that are collecting information from whatever source you're using. So that would be a way that you populate your Influx database instance, probably using Telegraph plugins is one way. And then you can also just kind of manually configure it to collect metrics from whatever source that you're collecting metrics from. So it depends on what you're asking, whether you're talking about kind of playing around with it locally. You can use the CLI, or you can use the write endpoint, which I showed you earlier, or you can use Telegraph plugins to collect your metrics.
Great. The next question that we have is a time series database a good solution for change tracking placed over top of an enterprise data warehouse?
I don't really know the answer to that question. I suspect the answer is yes. Chris, do you have any additional insight on that?
Yeah, I mean, I think you kind of answered the question by yourself, the person who asked the question. So yeah, anytime you're tracking any kind of change, anything, whether it's you want to understand the performance of your CI/CD or the blades of your wind turbines or the server speed, anything that you're tracking to make sure that you can understand whether performance increase or decrease, you would put that kind of data into a time series database to track that information and then take some kind of action. So it really is, I mean, the capabilities of it and also the use cases are, are quite interesting, and there's many of them.
Awesome. The next question that we have is, can I use Grafana with InfluxDB?
Yes, you absolutely can. In fact, many people do. And little plug, we're going to be at GrafanaCon. Paul Dix, our CTO, is actually going to be talking there. So yeah, a lot of people use Grafana with InfluxDB.
And I think I'll also add that actually probably the most popular visualization that we'll see with InfluxDB is going to be a custom visualization, because a lot of our users may build, let's say they have a smart thermostat that they're selling to their consumers, and they have a smartphone app that is attached to it. And in the smartphone app, they might have some kind of graphing capability to show their consumers, how well the thermostat is performing. So in a lot of cases, the most popular form of visualization that our users present to their users is going to be something that they built themselves. When they're actually using the data to look at how well their operations are performing is typically when they're going to use a product like Grafana or Chronograph.
Great. The next question that we have is, how is data written and stored to disk that make the differences between TimeSeries database and RDBMS?
I don't know the details of how that exactly works. So that might be something that we can ask in the community channel, unless, Chris, you have some input on that.
Yeah, I mean, so the one characteristic that Sonia talked about when it comes to TimeSeries data is a lot of times as it's being generated, it's generated in based on the time that this measurement was captured, and when it's thrown into disk, it's usually in that kind of sequential order. So given that, it's one of the great things about TimeSeries databases is that they're already optimized for time, so you don't even have to think about that. So you can write that data very quickly in there. And if if there is any kind of a change in the data, which usually there shouldn't be, because when you're collecting that value at that given time, you usually don't make a change to that because you're trying to capture something in real time. But sometimes maybe some of the other, sometimes data comes in later, but it'll just write over that data that's being that has been already captured. The other thing is, I think Sonia talked about this, is that not only is the data being written in that sequential order, but you can set different kinds of retention policies, and you can downsample that data. So there's like automatic ways for you to be able to take data out of the data store so that you can be a lot more efficient with your storage. And also, I think it's kind of interesting that with time series data, over time, the precision of that data isn't as important. You just really want to be able to understand kind of the shape of the data. You might be able to, for historical purposes, you don't really need to be able to hold all that information, and so you can discard some of that stuff. Hopefully that answered your question.
Awesome. Looks like we do have one more question. Question is, what is the performance of OLAP queries on InfluxDB?
I don't know the answer to that one. Can you state that again? What kind of queries? I don't even know what kind of queries those are.
OLAP queries?
OLAP queries. I'm not familiar with OLAP queries. Sorry.
Yeah, the way that we do our querying is we don't use OLAP queries, as Sonia mentioned. We have a form of SQL that is really easy to use. It's really simple to get started with it. And as Sonia also mentioned, we're also extending that to a new query language called Flux. And between the two of them, you can do pretty much any kind of query that you might do with an OLAP type query when you're trying to bring in data, from your BI tools. But it's a little bit different, but the capabilities are similar.
Awesome. Well, I would like to thank you, Sonia, for a wonderful presentation today. I'd also like to thank today's sponsor, InfluxData, for providing the audience with a great webinar presentation. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day, and we will see you next time.